The question that we're going to cover today is the longest substring without repeating characters. The title basically says what you need to do. There are, however, two constraints given. The length of the array can be up to 5 times 10 to the 4th, and the possible characters include letters, digits, symbols, and spaces. The first thought come to your mind might be a relatively brute force solution, in which you would like to enumerate all the substrings and find out the longest one or ones that satisfy the condition. However, in a given string S, there are up to n to the square substrings you will need to enumerate. You need to enumerate all the left and right boundaries. This is n squared. Now, once you enumerate the substring, you still need to take O(n) time to scan through the string and find out if it's valid or not. So this is another O(n) complexity. This will eventually result in n cubic complexity, which is pretty slow. Now, is there a more efficient solution? In fact, if you dig deeper into this n cubic solution, you'll realize that there are many redundant checks that you could avoid. For example, if you already know that the current string has duplicates here and here, they're the same, then so do all other substrings that contain this current one. All the extended ones will face the same issue, so they are all invalid. Now I'm going to propose a different substring searching process. Let's say if we now fix the left boundary here and keep extending to the right. If we now see for a new extended character here, let's say it's an A, and repeat with a previous one, A here. What should we do? We should not extend rightward anymore because they will all be invalid. But instead, I should move my left boundary to here. After I do that, there's only one A in the substring, so I can keep extending to the right. And that's basically the strategy we're going to use. And let's call it sliding window. If you think more about this strategy, it is guaranteed to scan through all the valid strings, but with a much better time complexity. It's because both the right and left boundaries will only move to the right. So in an amortized complexity, it's only O(n). This is called the sliding window technique. And let's now quickly take a look at this pseudocode. We have function here. We know the length of the string is n. We'll need to default the boundaries to 0 and maintain a max length. We'll move the right boundary to the right gradually. Every time we'll check if this character is in a set or not. If it does, then we should try to pop the character from the left boundary. We'll need to remove SL until SL equals to SR, and we'll do a break. No matter what, we'll need to always add SR. Afterwards, we also need to update the max length. And this is our final answer we want to return. This is a pseudocode, and now let's move on to the coding part. I'd like to start with getting the length of the string as a variable n. Also need to have a char set to keep all the characters in the current substring. This set is default to an empty set. The L boundary will be default to 0, and the maximum length will also be default to 0. I'll start iterating this R variable from 0 to n-1. And then let's call this new character R, which is equals to S at R. Now there will be two possibilities. One is that this character R is already in the character set. We'll need to do some cleanup. And afterwards, we'll need to add this character R into the char set. What kind of cleanup are we talking about? As we mentioned in the pseudocode, we'll need to move the left boundary around. While L smaller than R, we'll first get this character L, which is S at L. We'll need to move this character L from the set. And then L needs to also equals to 1. We'll need to keep doing this while loop until the point that we actually remove the characters that we want to move, which is the character R. If this happens, we can quit, and we'll add this new character into the set. After doing this, we would like to update the maximum length we can get, which is maximum of maximum L and R minus L plus 1. Remember that we need to plus 1 here because the R and L, they are all inclusive. At the end, we'll return this maximum length. Now let's see if it works. Cool. 3 test cases are passed, and now let's do summation. All right, you can see it beats around 80% of the users. And that's the end of this video. Thank you for watching.